We're going to continue using the idea of interval notation to write down the domain of functions. We need to be given a function and its output rule. So just looking at three very basic functions, we might look at a polynomial function, maybe x cubed minus 4x plus 9. So a polynomial function would be the sum or difference of terms, each term just being a product. So we have sum and difference of terms. There is no division, meaning we don't divide by the input, and there's no radicals. That would also mean there's no fractional exponents. So this is just a typical polynomial degree 3. Its domain is going to end up being all real numbers, all x that are elements of the real. Graphically, that would be the entire number line. So there would be no left bound and no right bound. In this context, the infinity symbol is a symbol, not a value. So it means there is no left endpoint. So since there is none, we leave that open by convention. Two more. I mentioned a radical function. This could be a square root type function. I'm just going to go ahead and make it a very simple square root of x. And then on our test, I believe we saw, and this would be a typical example. We saw an example of a reciprocal function. So whatever number you plug in, the output is its reciprocal. Okay. So the domain, the function f, is all real numbers because f is a polynomial. There is no risk of dividing by 0. There's no risk of taking the square root of a negative number. On the other hand, the domain of G are only the non-negative values on the number line. Now we can find the output of G when the input is 0. The square root of 0 is 0 because 0 squared is defined and we give you 0. So 0 is in the input. It's one of the possible inputs of G. It's in the domain of G, and we have to close up that endpoint, this half-open interval for the domain of G. And then we can divide by any other, we can take the square root of any positive value, but we don't want to include anything to the left of 0 in the domain of G because we don't want to take the square root of something negative. For example, G applied to -1, we would be trying to take the square root of -1. And that would be what we call I, which is a complex number that's not real. And so we aren't getting a real output when we plugged in that value for G. However, it was okay to plug in -1 for f because it's okay to cube -1. It's okay to take -1 times any real number. And we can end up combining all these values. You might want to double check me on that, but I think we get -1 plus 4 plus 9. So the output of f of -1 would be 12. Just to compare that G of -1 was not defined. Okay, so that I don't get out of frame, I'm going to write our domain of R up here. This function, if students miss a domain of a function, this typically is where they don't slow down and think a little bit harder. We can take the reciprocal of any number but 0. We don't want to divide by 0. No division by 0. We could take 1 over 2. We could take 1 over 10. We could take 1 over anything large. But we can also take the reciprocal of fractions less than 1. The domain of this function is all real numbers up to 0, but we have to skip over 0. If we were going to draw that domain for R on a number line, we would shade in everything to the left of 0, everything to the right, but we wouldn't include 0. Okay, so let's stop there for part 1. And we'll start over with a little bit more complicated functions and continue to find the domain of functions that contain some radicals or division, or sometimes we spot they don't have radicals or division at all.